We now solve a separable differential equation. Y prime is equal to y squared minus 4 times x cubed. Okay. A differential equation of first order is called a separable equation if we have this form: y prime is equal to a function of y multiplied by a function of x. And here we see clearly this equation is a separable equation. Okay, so to solve a separable equation, we follow certain procedure. We say, okay, y prime is really just dy dx, and is equal to y squared minus 4 and x cubed. So we try to move everything about y variable to the left-hand side and everything about x to the right-hand side. So we multiply both sides by dx and divided both sides by y squared minus 4. So this is what we have. So we have 1 over y squared minus 4, and dy is equal to x cubed and dx. Now we integrate both sides. So now we integrate both sides. We have 1 over y squared minus 4 dy is equal to integral and x cubed dx. Okay. We see the right-hand side is easy to integrate, so we just write down this is going to be 1/4 x to the 4th plus c. Now let's look at the left-hand side. We have integral 1 over y squared minus 4 and dy. And since y squared minus 4 we can factor as y minus 2 and y plus 2. We see this is a typical example where we can use integration by partial fraction. So now we're going to try to decompose this fraction into a sum of simpler fractions. It's some kind of a over y minus 2 and plus b over y plus 2. Okay. Now we look at the right hand side, and the common denominator should be exactly y squared minus 4, and then on top we have a times y plus 2 and plus b and y minus 2. So now we multiply the numerator out. On the right hand side we will have y squared minus 4 is the denominator, and on the left hand side we have 1. On the right hand side we have a y plus 2a and plus by minus 2b, and we collect the terms according to the degree of y. So we have a plus b times y, and then plus 2a minus 2b. Now we compare with the left-hand side. Left-hand side, we have constant 1, and we don't have any y. That means 0 times the y plus 1. So now we have two equations. A plus b must be 0, and 2a minus 2b must be equal to 1. So we can see that b is equal to negative 2a, and substitute inside we have 4a is equal to 1, so capital A is equal to 1/4, and b is equal to negative 1/4. What it means is that 1 over y squared minus 4 can be decomposed into two simpler fractions. One is 1 over 4 y minus 2, and the other one is negative 1 over 4 and y plus 2. Now we put this back into the equation so we can actually integrate this one out. So now we have on the left hand side 1/4 y minus 2 plus 1 negative 1 over 4 over y plus 2, and dy is equal to 1/4 x to the 4th plus c. We now can simplify this a little bit by multiplying 4 both sides and integrate. So what we have is 1 over y minus 2 minus 1 over y plus 2 dy is equal to x to the fourth. Now here should be 4c, but we know c is an arbitrary constant, so we don't have to do that. Just another constant c. And then we integrate, we have log y minus 2 minus log y plus 2, and that's equal to x to the fourth plus c. If we combine these two logarithms together, we have log y minus 2 over y plus 2, absolute value we can use, and is equal to x to the fourth plus c. Or if we exponentiate both sides, then we have y minus 2 over y plus 2 is equal to e to the x to the fourth plus c. Now we can simply write this one in the form of e to the x to the fourth times e to the c. But e to the power c is just another constant, so we can say the final answer is absolute value y minus 2 over y plus 2 is equal to another constant c and e x to the fourth. Now, because this constant c now can be positive or negative, we can actually further simplify. So what we have over here is that y minus 2 over y plus 2 should be equal to c e to the x to the fourth. Let's even do a little bit further, because sometimes we do hope to solve y explicitly, so we can actually do this. So now let's go a little bit further to the right, and y minus 2 is equal to c e to the x to the fourth and y plus 2. So we have y minus 2 is equal to c e to the x to the fourth times y plus 2c e to the x to the fourth. Now we cannot just say this 2c is just another constant, because c already appeared over here. So we need to keep this c. All right, and then what do? We combine, we put this term, move this term to the left, and negative 2 to the right. So we have y minus y times c e x to the fourth, and that's going to be 2 plus 2c e to the x to the fourth. Now we pull out y, so we have y times 1 minus c e to the x to the fourth, and it's equal to 2 plus 2c e x to the fourth. So now we can solve y. This unknown function is equal to 2 plus 2c e to the x to the fourth, and divided by 1 minus c e to the x to the fourth.